Hello everyone, my name is Sandeep Singh and our second video assignment is for EDA. In this video assignment we will look upon to the knapsack problem. The knapsack problem is optimizing treasure retrieval. The knapsack problem is a classical optimization challenge where you must select the pack into limited capacity backpack to maximize the total value. The fundamental problem has an application in logistic resource allocation and even video game design. Defining the knapsack problem, the first one is the challenge. Given a set of items, each with a weight and a value, determine the number of each item to include a collection so that the total weight is less than or equal to given limited and the total value is larger as possible. Key variables: the weight capacity of the knapsack, the weight of each item, and the value of each item are the key factors that must be considered. And the goal: the objective is the main maximize the total values of item in the knapsack while staying within the weight limit. Here are the advantages of brute force for knapsack problem. First one is simplicity. Brute force is a straightforward approach that is easy to implement and understand. Second one is guaranteed optimal solution. Brute force will always find the optimal solution as long as the problem size is manageable. No assumption. Brute force does not require any assumptions about the problem structure or the data. Fourth one is flexibility. Brute force can be easily adapted to handle various of the knapsack problems. Here are the limitations of brute force for knapsack. Exponential time complexity. The time complexity of brute force for knapsack problem is exponential, making it impractical for large problem sizes. Memory constraints. Brute force can require a significant amount of memory to store all possible solutions, which may be feasible for large problems. Scalability use. As the number of items and the weight capacity increases, the problem size grows rapidly, making brute force computationally infeasible. Lack of efficiency. Brute force may not be the most efficient approach for solving the knapsack problem, especially when the optimized algorithms are available. Now we will move to when to use brute force for knapsack. Small problem size. Brute force can be appropriate for the knapsack problem when the numbers of items and the weight capacity are relatively small, such as less than 20-30 items. Educational purpose. Brute force can be useful for teaching tool to demonstrate the basic concept of knapsack problems and the limitation of this approach. Prototype development. In the early stages of a project, brute force can be used quickly prototype and test the feasibility of knapsack problem solution. Brute force algorithm for knapsack. Recursive brute force. This approach recursively explores all possible combination of items, keeping track of the best solution so far. Second one is iterative brute force. This method uses nested loop to generate all evaluated possible combination of items, similar to recursive approach. Bit manipulation. This technique represents each item as a bit in a binary number and uses bit manipulation to generate and evaluate all possible combinations. As you can see in the diagram, here is a question to find the sum of 6 number algorithm. So in first case we are initializing the sum equal to 0 and count equal to 0. Then we are entering n, and third one is find the sum plus n and assign this to sum. Then increment by count 1. If count is less than 6, is count is less than 6? If yes, go to step 2. If no, print sum. As you can see in the flow chart. First we have start and set count and sum 0. Then we have entered the n value. Then the sum will add the n value and the count will add 1. Then if the count is less than 6, it will print. If not, it will go to step 2. Now implementing brute force of knapsack. First one is pseudocode, the higher level setup to implement a brute force solution for the knapsack problem. Python example, a simple Python implementation, the brute force approach to the knapsack problem. Third one is time complexity. The time complexity of a brute force solution is O to the power 2n, where n is the number of items. Optimization techniques to improve the efficiency of a brute force approach such as memorization or purring. purning. Now we are comparing brute force and dynamic programming. Basically, we are comparing brute force to the dynamic programming. First one is we can see approach, time complexity, memory usage, and optimally. If brute force is there, then the time complexity will be O to the O to the power of n, and memory uses will be 0 1. And optimal, it is optimal. And in dynamic programming we can see O into n into W. So the memory uses will be the same as O n into W, and the optimally is the optimal. Optimizing brute force for knapsack. First one is memorization, storing all the result of previously calculated subproblems to avoid redundant computation. And second one is purning, integratedly eliminate branches of search tree that are unlikely to lead the optimal solution. Third one is parallelization, dividing the problem into smaller subproblems and solving them concurrently on multiple processors. Now we will move to the conclusion of this knapsack problem. Exploring the knapsack problem, we have explored the knapsack problem. First one is understand the trade-offs. Brute force is a simple and intuitive approach but it has no limitation in the terms of scalability and efficiency. Second one is consider alternative algorithms. For larger problem size, dynamic programming or the other optimization techniques may be more suitable. And the third one is experiment and innovate. The knapsack problems offer opportunities to explore new algorithm and problem variations.